Hello everyone. Today we are going to discuss about the formation of image in plane and spherical mirrors from reflection of light. Now look at these pictures. What are these? Yes, they are different types of mirrors. So, a mirror is a smooth surface on which regular reflection takes place. Actually, a mirror is made by giving a reflecting coating on the smooth surface. Generally, a mirror is prepared by giving metal coating on one surface of glass. This process of coating with mercury, silver or aluminum on glass is called silvering. Here, 4% light is reflected from the front part of the mirror, but the back part reflects fully and forms the original image. Mirrors are of mainly two types: plane mirror and spherical mirror. If the reflecting surface is plane and smooth and regular reflection of light takes place on it, then this surface is called plane mirror. The mirror which we usually use is plane mirror. If the reflecting surface is smooth and spherical, that means if the reflecting surface is a part of a sphere and regular reflection takes place on it, it is called spherical mirror. If a part of a hollow glass sphere is cut off and silvering is done on one surface, then a spherical mirror is made. Spherical mirrors are two types: concave mirror and convex mirror. If the concave surface of a sphere acts as the reflector, that is, if regular reflection of light takes place from the concave surface of the spherical mirror, then it is called a concave mirror. In this case, concave mirror is made by silvering on the convex surface of the part of the sphere. Convex mirror. If the convex surface of a sphere acts as the reflector, that is, if regular reflection of light takes place from the convex surface of the spherical mirror, then it is called a convex mirror. In this case, convex mirror is made by silvering on the concave or inner surface of the part of the sphere. Look at these figures. Here the figures show the formation of images in plane, concave and convex mirror. In the second picture, we see front plane of the spoon works as concave mirror and the opposite plane works as convex mirror. Now let's see some other uses of spherical mirror. In all types of mirrors, image is formed. So, what is image? If light rays diverging from a source incident on a reflecting or refracting surface, then after reflection or refraction, the reflected or refracted rays either converge to a second point or they appear to diverge from a second point. This second point is called the optical image of the first point. Images are of two types: real image and virtual image. Real image. If light rays emitted from a point after being reflected or refracted on a surface actually converge at a second point. then this second point is called the real image of the first point. In this figure, A prime B prime is the real image of the object AB due to reflection on a concave mirror. Virtual image. If light rays emitted from a point after being reflected or refracted on a surface seem to diverge from a second point, then this second point is called the virtual image of the first point. In the first figure, A prime B prime is the virtual image of the object AB due to reflection on the convex mirror. And in the second figure, for the point object, a virtual image is formed at the back side of the plane mirror. Now let us discuss the differences between real and virtual images. 1. If a pencil of rays diverging from a point source after reflection or refraction converges to a second point, then the second point is called the real image of the first point. Virtual image. If a pencil of rays diverging from a point source after reflection or refraction diverge to a second point, then the second point is called the virtual image of the first point. 2. Real images are formed by the actual convergence of the reflected or refracted rays. In the case of virtual image, reflected or refracted rays do not actually converge to a second point. 3. Real images are seen by eyes and they can be received on the screen. Virtual images are seen by eyes but they cannot be received on the screen. 4. These images are formed by concave mirror and convex lens. These virtual images are formed by all types of mirrors and lens. 5. Real images are generally inverted. 5. Virtual images are generally erect or straight. Reflection on plane mirror. Now look at the two figures. In the first figure, X is an object from which incident ray XO falls on point O and reflected along the ray OR. Another ray from X falls on the mirror at the point P at 90-degree angle. If we extend these rays behind the mirror, then they will seem to converge to a point X prime. This point is the image of X. In the second figure, how an image is formed for an extended object been shown. Light coming from point X and Y reflect from the mirror and form a virtual image at point X prime and Y prime, respectively. That is, light appears to coming from X prime, Y prime. We can clearly see that length of XY is equal to the length of X prime, Y prime, and the arrowhead of the XY, Y prime is to the same direction of the XY. So, the image formed in a plane mirror is equidistant from the mirror, virtual, straight or erect, and equal to the size of the object. Now let us discuss some terms related to spherical mirror. Here, M prime is the spherical mirror. P is the pole. C is the center of curvature. AB or AP is the principal axis. A prime P prime is the secondary axis, and CP is the radius of curvature, that is denoted by small r. Reflection on spherical mirror. Here we see two figures. First one shows the reflection on concave mirror, and the second one shows the reflection on convex mirror. Here F is the principal focus in concave mirror and on convex mirror, and small f is the focal distance from principal focus to pole. Here F is the principal focus in concave mirror and convex mirror, and FP is the focal distance F. In case of concave mirror, a parallel beam of light rays incident on the concave mirror, and after reflection the rays converges at a point. This point is called principal focus of the mirror. Looking at the picture, we can see focal length is FP, which is denoted by small f. CP is the radius of curvature, that is denoted by small r. And so we can say CF equals to FP equals to r by 2. So F equals to r by 2. That is, focal length is the half of the radius of curvature. Similarly, in case of convex mirror, a parallel beam of light rays incident on the convex mirror, and after reflection the rays appear to be diverse from a point on the principal axis. This point is the principal focus of the mirror. So F is the principal focus. FP is the focal length, which is denoted by small f. CP is the radius of curvature, which is denoted by small r. So CF equals to FP equals to r by 2. That is, F equals to r by 2. That is, focal length is the half of the radius of curvature. So what did we learn? We learned about plane mirror and spherical mirror, uses of plane mirror and spherical mirrors, about images, real image and virtual image and differences between them, process of formation of images in different types of mirror, and description and uses of concave and convex mirror. That's all for today. Thanks for watching.